Morning students, I think this is the second session of your chapter circles. In the first session we already learned some basic concept that is related to circles. For example, center of the circle, definition of circle, radius, diameter, arc, segment and sector, right? So today we are going to discuss some theorems based on the chords. Okay, in that first theorem is, the statement of the theorem is, the line drawn through the center of circle to the bisect a chord is perpendicular to the chord. Clear? When you draw the line from the center of circle to any chord, that is always perpendicular to the chord, and that chord is divided into two equal parts. Okay, so here we need to prove the given statement. So O is the center of circle, O be the center of circle, and AB is a chord. AB is a chord. If I draw the line from center of circle to chord, it bisects the chord into two equal parts. So M is the midpoint of the chord. AM is equal to BM. Okay. Next. So write first given. What are the given things here? A circle with center O. Circle with center O. OM is line bisects the chord, bisect chord AB, bisect the chord AB. Bisect the chord AB means that is AM is equal to BM. AM is equal to BM. Okay. Next one. What you have to prove in this statement? You need to prove OM is perpendicular to the chord AB. OM is perpendicular to AB. OM is perpendicular to AB. Construction. Join OA and OB. Join OA and OB. So join OA and OB means, if I draw the line from the center of circle to the circumference of circle, these two lines or line segment act as a radii of the circle. So OA and OB are the radii of the circles. Okay. Next one, proof. By joining these 2 points, here you will get two triangles. What are the two triangles? Triangle OAM and second triangle OBM. Directly consider that two triangles. In triangle OMA and triangle OMB. In triangle OAM and triangle OBM. So in these two triangles, OA is equal to OB. OA is equal to OB. Reason, radii of circle. These two are the radii of circle. Okay. Next, OM is equal to OM. OM is the common side for the both two given triangles. So OM is equal to OM. That is common. And next one, AM is equal to, the length of AM is equal to BM. AM is equal to BM. It is already given in the statement. The line drawn from the center of circle to chord, that is bisected into two parts. So these are the two equal parts, AM and BM. Therefore triangle OMA is congruent to the triangle OMB by using the congruence criteria? Yes, yes, yes. Right? So, if these two triangles are said to be congruent and the remaining all parts of the congruent are equal by using CPCT. CPCT means corresponding parts of the congruent triangles. So, angle OMA is equal to angle OMB by using CPCT, corresponding part of the congruent triangles. If these two angles are equal, then remaining all angles is also equal. So we need to prove that here OM is perpendicular to AB, right? So consider that given two angles OMA plus OMB. Angle OMA plus angle OMB is equal to 180 degree, because these two are the linear pairs, no? In that one angle OMA is equal to OMB. So take it any one angle OMA plus angle OMA is equal to 180 degree, or AMB is a straight line. Right? So 2 times of OMA is equal to 180 degree. Then angle OMA is equal to 180 divided by 2, that is equal to 90 degree. If angle OMA is 90 degree, means one more angle is also 90 degree. Angle OMA is equal to angle OMB. Both two angles are 90 degree. Hence, OM is perpendicular the chord AB. OM is perpendicular the chord AB. This is the proof of the given statement. Right? So, what we are proving here? The line drawn from the center of circle to the chord, the chord will bisected and is perpendicular to the chord. Okay, let's move to the second theorem, that is when the line drawn from in first theorem, what you are discussed, the line joined from the center of circle to the chord, that is always perpendicular, right? In second statement or in second theorem, the statement of the second theorem is the perpendicular to a chord from the center of circle bisect the chord. The perpendicular to a chord from the center of circle bisect the chord. Okay? So, take one circle, the center of the circle is O. OM is perpendicular to the chord AB. OM is perpendicular to the chord AB. So you need to prove that the length of the chord is exactly divided into two equal parts. When the line drawn from the center of circle to a chord and it is perpendicular, the chord is bisected. The chord is bisected into two equal parts. So first write the given. What is the given part? A circle with center O, and one more thing is already given. OM is perpendicular. OM is perpendicular to AB. OM is perpendicular to chord AB. What you have to prove here? To prove the length of the chord is bisected, it means the chord is divided into two equal parts. So AM is equal to BM. You need to prove that AM is equal to BM. Construction. Again, similar to the first theorem only. This is the converse theorem of the first theorem. So join OA and OB. OA and OB are the radii or radius of the circle, given circle. Okay. By joining these two radii, we get here two triangles. What are the two triangles? Triangle OAM and triangle OBM. So consider that two triangles. In triangle, what is that first triangle? Triangle AOM and triangle BOM. In triangle AOM and BOM, OA is equal to OB. OA is equal to OB. Reason? Because they are radii of the circle. Radii of circle. Next, OM is equal to OM. OM is equal to OM is the common side for the given two triangles. So OM is the common side. Next, OMA angle OMA is equal to angle OMB. Each angle is 90 degree. They are already given in the statement. OM is perpendicular to AB means, so these two angles are 90 each, right? So triangle AOM is congruent to the triangle BOM by using the RHS property. RHS property means the right angle triangle, right angle and hypotenuse and side of the given triangle. So here triangle OAM and OBM are two right angles. OA and OB are the hypotenuse of the triangle and OM is the one of the side of the given right angle, and these two OMA and OMB are the right angles of the triangle. So if two triangles are said to be congruent, then the remaining all part of the triangles are equal by using CPCT. So the length of AM is equal to BM. AM is equal to BM by using CPCT. Hence, we proved here the line drawn from the center of circle and it is perpendicular. That perpendicular line bisects the chord into two equal parts, that is AM is equal to BM. In first two theorems, we are discussing on the chord. That theorem first 1 and 2 related to the chord, right? In third theorem, the statement of the theorem is equal chords of a circle are equidistant from the center. If I take two equal chords in the particular circle, then that two chords are exactly equidistant from the center of the circle. Okay, so this is a circle and center of circle is O. O is the center of circle. Take two equal chords. AB is the first chord and CD is the second chord. AB and CD are the two equal chords, right? If I draw the line from the center of circle to the chord, it is always perpendicular, and that perpendicular divides the chord into two equal parts. You are already learnt in theorem 1, right? So AM is equal to BM. Draw one more line from the center of circle to the chord CD. ON. ON is the line drawn from the center of circle to the chord CD, and these two are perpendicular to the given chords. Okay, so write first given. A circle with center a circle with center O, and one more thing they are given here, two equal chords. What are the two equal chords? AB is equal to CD. AB is equal to CD. These two are the equal chords of the circle. Okay. To prove, what you have to prove in that given statement? When the line drawn from center of circle to the any chord, these two, it means the perpendicular lines, you need to prove that the perpendicular lines OM is equal to ON. OM is equal to ON. Okay. Next, construction. Join OB and OD. Join OB and OD. By joining these two, we get again two triangles. What is that first triangle? Triangle OBM and triangle ODN. So these two are the right angle triangles. Okay. When the line drawn from center of circle to chord, that chord will be bisected into two equal parts. So here BM, the part of the chord BM is half of the whole chord AB. Half of the whole chord AB. Similarly, DN is equal to half of the second chord CD. First one, this is considered as a equation 1 and this one is a equation 2, right? Next, AB is equal to CD. This is already given. This is already given in the statement. Consider this as a equation 3. Okay. BM is a half of AB, DN is a half of CD and two equal chords. Therefore, BM is equal to DN. The length of half length of the first chord equal to half length of the second chord. BM is equal to DN from equation 1, 2 and 3. Okay. BM is equal to DN. Now take two right angle triangles here. What are the two right angle triangles? In triangle OBM and triangle ODN. OBM and ODN are the two right angle triangles. In that, OB is equal to OD. OB is equal to OD. Reason? These two are radii of circle. Radii of circle. Okay. Next, BM is equal to DN. This is already proved, right? BM is equal to DN. Next, angle OMB is equal to angle OND. OMB is equal to OND. Each angle is 90 degree. Therefore, triangle OBM is congruent to the triangle ODN. By using the congruence property of RHS, if two triangles are said to be congruent, then their remaining all parts are equal by using CPCT. Therefore, OM, the length of OM is equal to ON. It means the line drawn from the center of circle to the both chords are equidistant from the center of the circle, or the line drawn from the center of circle to the given two equal chords, the distance OM and ON are equal. Let's move to the next theorem, that is the chords of the circle equidistant from the center of the circle are equal. The chords of the circle equidistant from the center of the circle are equal. This is the converse theorem of the previous one. In the previous theorem, what we proved? OM is equal to ON. OM is equal to ON, right? It means the line segment drawn from the center of circle to any chords. If you are taking two chords, the distance between the center of circle to chords are equal. It is already proved in the previous theorem, right? So in this theorem, again we are taking two chords. We need to prove that the length of the two chords are equal. The length of the two chords are equal. Clear? So right here, what are the given points? Again, a circle. What they gave here? A circle with center O. O be the center of circle, right? Next, OM is perpendicular to the line. OM is perpendicular to AB, right? ON is perpendicular to CD. If OM is perpendicular to AB and ON is perpendicular to CD, OM is equal to ON. OM is equal to ON. So what you have to prove here? To prove that length of the chords are equal. It means the length of chord AB is equal to chord CD. You need to prove that the length of the two chords are equal. Okay. Next, consider the construction part. As we are already constructed in the previous theorem, similarly here also join OB and OD. OB and OD. OB and OD are the radii of the circle. By joining these two radii, again we get a two right angle triangles. First one is triangle OBM and second one triangle ODN. Consider that two triangles. Proof. In triangle, what are the two right angle triangles? Triangle BOM and triangle DON. Triangle BOM and triangle DON. In that, OB is equal to OD. OB is equal to OD. These two are the radii of circle. Radii of circle, right? OM is equal to ON. This is already given in the statement. The two chords are equidistant from the center of the circle. So this is given, right? Next, consider the right angles from each triangle. Angle OMB. Angle OMB is equal to angle OND. Each angle is 90 degree, right? Therefore, triangle BOM is congruent to the triangle DON by using the criteria, congruence criteria of RHS. If these two triangles are congruent, then their corresponding all sides and all angles are equal, right? So BM is equal to DN. BM is equal to DN by using CPCT. CPCT means what? Corresponding parts of the congruent triangles. If two triangles are said to be congruent, in that the remaining all angles and all sides are equal, right? So BM is equal to DN. Now observe the length of BM and DN. As we already studied in the first theorem, the line drawn from the center of circle to any chord, that chord will be bisected into two equal parts, right? So BM and DN are the half of the each individual chords, half part of the each individual chords. Okay, so BM can also be written as half of AB. This is the half part of the whole chord AB, and DN is a half part of the second chord, that is CD. Now 1 by 2 and 1 by 2 neglects on both sides. What are the remaining? AB is equal to CD. The length of the chord AB is equal to CD. So when the line drawn from the center of circle to two chords, if the line is having equal distance, the length of the chord is also equal. Hence we proved the length of the two chords are equal, right? So these all are the theorems based on the chords. Okay, in first theorem what we discussed, just I can revise 4 theorems. In first theorem, when the line drawn from, if I take one circle and O is the center of circle, AB is the chord, right? When the line drawn from center of circle to the chord, it is always perpendicular and it bisects the chord into two equal parts, right? So OM is perpendicular to AB. OM is perpendicular to AB. And in second theorem, the chords divided into two equal parts, means we proved that AM is equal to BM. Suppose if the length of the chord is, just consider it as a 10 centimeter, when the line drawn from the center of circle to the chord, then if the length of the chord is, just consider it as a 10 centimeter. If the line drawn from the center of circle to the chord, that chord will be equally bisected. So each part of the chord is, AM is equal to BM, and half of the, or when we are dividing the 10 centimeter into two equal parts, what we will get? Each line segment having the length 5 centimeter. Okay. Next, in third theorem, we learned that in any circle, if the length of two chords are given, then the distance between the chords and centers are equal. It means we already proved that the line drawn from the center of circle to any chord is always equal. In the fourth theorem, they are giving the length of the line drawn from the center of circle to any chords are equal. It means OM, the length of OM is exactly equal to the length of ON. By using that, we need to prove the length of these two chords, chord AB and chord CD are equal. So these are all the theorems which is based on the chords. In the next class, we will study about the angles based in the interior part of the circle and the angle subtended at the circumference of the circle, and some theorems which is exactly based on the segment of the circle. Okay, be happy, be safe, have a nice day. Thank you.